All right, so today we're going to finish up with our Fred functions and learning how our transformations apply to functions and graphs on the coordinate plane. We did finish up our transformations yesterday. We said that with functions we don't do rotations. So we've only had to learn translations, dilations, and reflections. So what happens when we put all of these together? Or what happens when we do shapes that aren't just straight lines, but actually do have curves? And so those are some of the things that we're going to discuss today. So today we are dealing with d of x, dipper. Kind of looks like a little, little dipper, kind of like the constellation. Let's talk about our characteristic points. We want to find our characteristic points. So this is 1, 2, 3, 4, -5, -1. And then we've got -2, -3. And we've got 1, -1. And we've got 1, 2, 3, 4, 5, 6, 7, 0. So those are our characteristic points. Do notice that what's different about differ from the functions we've already used is this one has curves. Notice that between these 2 points and this critical point, this is a curved line. It's like a circle, almost like the bottom of a parabola. So we got the furthest down that it went was one of our characteristic points. And so we do have a curve. Now this is still a straight line. Now we want to look at making some changes to dipper. So if we look, these are the changes that we want to make to dipper. And if you read the steps down below, it kind of walks you through the first one. I'm going to do it with you here. But first we need to determine what are the changes that are happening. I notice that it's adding on the inside, and I know that adding is going left. So I'm going to need to go left 3 places. I know adding on the outside is going up, so that means it's moving up 5 places. Those are both translations. And then I notice that it's being multiplied by 2, which we said would give us a vertical stretch of 2. So everything's going to get multiplied by 2. All 3 of these things need to happen. Now, what I do want to point out is that the order that you do these transformations does actually make a difference sometimes. So when I'm counting these on the graph, it is a lot easier for me to do the vertical stretch first, figure out how far away from the axis it's supposed to be, then I can go left 3 and up 5. So that's how I'm going to make those changes. But that's the order that it follows here. So if I pick a point, how far away from the axis is that point? It's 1. So for my vertical stretch, instead of being 1 away, I want it to be 2 away, which brings me to right here. Now, I need to go left 3 and up 5. So left 1, 2, 3, and then up 1, 2, 3, 4, 5. This is where I landed. So if this is A, this would be A prime, because we had like 3 changes there. So I stretched it. So instead of being at 1, it came to 2. And then I went left 3 and up 5. And that's the order that you want to do these in. So for this point, it's 3 away. 3 times 2 is 6. So 1, 2, 3, 4, 5, 6. I stretched it. So it's at 6. Now I want to go left 3 and up 1, 2, 3, 4, 5, which actually puts it right here. Now this one's 1 away, so I want it to be 2 away. So that's right here. I'm going to go left 1, 2, 3, up 1, 2, 3, 4, 5. And then this one is on it. So 0 times 2 is still 0, so it stays on it. But it does need to go left 1, 2, 3, up 1, 2, 3, 4, 5. So we said that between these 2 points it was a straight line, so I've got a straight line there, but we kind of want this circular bowl shape here, so we're going to make sure that we kind of get that little bowl shape going on there, and then that's going to give us our changed shape. So I stretched it, made it a little deeper. Notice that my bowl got deeper. It's not quite as shallow as this one. And it shifted left 3 and up 5. So that is how we go about changing dipper here. We followed it, we did all the points for it following these 3 steps. You can look over those steps and it breaks it down for you. Now let's look at another change to dipper here. When I look at this one, we want to remember what are the transformations that we want to do. So I'm subtracting 4 outside, so I'm definitely going to move down 4. That's a translation. And then I've got negative. I'm multiplying by a negative outside. Negative outside reflects over the x-axis. So we're going to reflect it over the x-axis. So just like with the dilation, I find it easier to reflect first and then make my translation. So that's what I'm going to do. So this one is 1 away from the axis, so I'm going to go 1 on the other side. So I reflected it first. You may find it easier for you to do 1 at a time. If you do, you may want to use different colors. So let's say I just want to do the reflection first. So I'm going to go 1 on the other side, 3 on the other side, 1 on the other side, and then this one stayed on. So this would be the reflection. Now I need to take that reflection and move it down 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So then I could just draw the final picture. It didn't get stretched any, it's still fairly shallow, but it did get reflected and then it did get moved down 4. So I reflected first, that's what these points were, and then I moved them down 4, and that got me my final resting place for dipper here. We did it for all 4 characteristic points, and we completed the graph for that one. Now, this one, when I look at it, let's see if we can figure out what's going on here. The negative is on the inside, so we're not reflecting over the x-axis, we're going to reflect over the y-axis. So we're reflecting over y-axis, and then we are multiplying by 3, so that's going to be a vertical stretch of 3. So what I'm going to do is, again, I need to know how far it is away from the y-axis. Or let's think about this one, because this is a vertical stretch. So I'm stretching it this way. That means I need to know how far away it is from the x-axis. But to reflect over the y-axis, that's going this way. So I need to think about which one do I want to do first. Now, here's the good news. There's no translation involved here. Translations should always be done last. Like, get those out of the way last. We want to know our distances first. But this one, the order that it goes in doesn't matter as much, but I really need to make sure that I keep myself straight. So what I think I'm going to do is that I am going to do my vertical stretch first, and then I'm going to reflect it over the y-axis. So for my vertical stretch, I'm stretching by 3. This one's 1 away. 1 times 3 is 3. So 1, 2, 3. So that's that one. This one's 3 away. 3 times 3 is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That gets me to here. 1 away is going to go to 3. And then 0 away, 0 times 3 is still 0. So it stays there. Now I can go and reflect it over the y-axis. So this one is 1 away from the y-axis. So I'm going to go 1 away on the other side. This one is 1, 2, 3, 4, 5, 6, 7 away. 1, 2, 3, 4, 5, 6, 7 away. This one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2. So now we know that this one is a straight line, and then this one is supposed to be the curved line. So it flipped over the y-axis, and we stretched it to make it a deeper scoop. If we did it in the other order, I can do it in the other order and show you that we would get the same thing. So I could reflect it first. So 7, 1, 2, 3, 4, 5, 6, 7. Move that over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This one's 1 on the other side, and then 1, 2, 1, 2. So I could have reflected it first, and then I could do my vertical stretch. This one's 0 away, so it's going to stay 0 away. That one's 1 away, so it's going to become 3 away. This one's 3 away, so it's going to become 3, 4, 5, 6, 7, 8, 9 away, because 3 times 3 is 9. 1 away becomes 3 away. So we get the exact same graph, whichever one we do first. So make sure you keep it straight which one you're doing. So now we've got lots of examples here that we can go through and try together. So first, identify what's happening. So this one's going up 5, and we've got a vertical stretch. And it is stretching by 3. So I'm going to do my vertical stretch first, and then I'm going to move it up 5. So when I look on here, this one's 1 away. 1 times 3 is 3. This one's 1 away. 1 times 3 is 3. This one's 3 away. 3 times 3 is 9. This one's 1 away, so that's going to become 3. 1 away is going to become 3, and 1 away is going to become 3. So that gave me my stretch first. Now I need to take those points and move them up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So I've got straight, and then it kind of gives me this heartbeat. There we go. And so this gives me my stretched and my translated. When we look at this one, we do have some curves here. So we need to identify what are our characteristic points. When we look at our characteristic points, we've got one here, one here, one here, and one here. But we also want to make sure we get the tops of these curves. They're going to be curves. They're not straight lines. They are like little parabolas or top of a cat. I think they're supposed to be cat ears with a name like Garfield. So these are kind of my characteristic points. What do I want to happen? I'm going to go down 6. I'm going to go right 3. And then I have to remember this is going to be a reflection, but it's outside the function. So we are going to reflect over the x-axis. So of those 3 things, this is probably what I want to do first. Get the reflection out of the way. So 1 away, 3 away, 1 away, 1 away, 3 away, 1 away. So I did that first. I reflected. Now I can worry about moving 3 to the right and 6 down. 3 to the right, 1, 2, 3, 4, 5, 6 down. 3 to the right, 1, 2, 3, 4, 5, 6 down. 3 to the right, 1, 2, 3, 4, 5, 6 down. 3 to the right, 1, 2, 3, 4, 5, 6 down. 3 to the right, 1, 2, 3, 4, 5, 6 down. And 3 to the right, 1, 2, 3, 4, 5, 6 down. I know these are little curves because they're like the little cat ears, and then that one was straight in between. And that gives me my reflected, translated shape. I didn't have to make a table. I didn't have to do any, equations. I just needed to know how it was going to move. So that's what you want to make sure that you're keeping track of. All right. So now I've got this shape. Again, I'm going to make sure that I know where my critical points are. I'm like, okay, this was a start and an end. We've got start and end here. And then when we have these circles, you just want to kind of find the furthest point, like the vertex, so that you can get that good curved shape. So that gives me 5 characteristic points. Now, there are still 2 things going on here. This negative outside is going to reflect over the x-axis. The 3 is going to give us a vertical stretch. So it is still two things that are going on. So I'm going to go 3 times the distance on the other side. So if I just reflect it and move everything 1 away on the other side, 3 away on the other side, 1 away on the other side, and 1 away on the other side, that's just the reflection. Now I need to do my stretch. 1 away becomes 3 away. 1 away becomes 3 away. 3 away becomes 6, 9 away. 1 away becomes 3 away, and 1 away becomes 3 away. So we get those 2 straight sides over here and a really stretched out parabola on this side. So we reflected it and we stretched it. I would like for you to complete this last page here on your own and have questions for me on Wednesday. And then you also have your class worksheet that you need to turn into the sub before you leave. And your homework is on Edmodo tonight. It is the review packet. And let's get ready to review on Wednesday for our test on Thursday.